and in today's video, we are going to do experiment 7, which is the traffic lights. So for the first procedure, we should construct the circuit shown below, which is, as you can see, similar to a traffic light. So for this one, load the given source code shown below in your Pi. So for that, we should type this code for our Raspberry Pi, and we are accessing the uh, monitor or the screen of our Raspberry Pi with VNC viewer, and as we can see, there is a tab open which is the Tony Tony Pi IDE or Tony Python IDE. So the code is already typed here. So to explain the code itself, so we import traffic lights from the GPIO 0 and time, and from the time we import sleep, which is from the time library we import the module sleep. So we can see lights is equal to traffic lights 234, which represents GPIO2, GPIO3, and GPIO4. So we turn on the green light, and based on the arrangement of this function, GPIO2 is red, GPIO3 is amber, and GPIO4 is green. So we turned on the GPIO4. So for the while loop, we can see that it has a delay of 10 seconds, which is sleep 10. Then the green light will off, then the amber will on with the delay of 1 second, and then the amber will be off and red will be on for a delay of 10 seconds. Then the amber will be on, and with the delay of 1 second, then the green light will be on and the two other lights will be off, which is the amber and red. And this code will go on since it is under the loop. So let's try to run this code with this one, run current script, and let's see what the circuit does. So we can see that the code is running and the green light is currently on for 10 seconds. Then as we can see, it turns on the amber and it goes to red for at least 10 seconds. So by this demonstration, we can see that the traffic lights are working properly like a traffic light system we saw on the roads. So for this one, this is an alternative code for the traffic lights. So we can see that it's the same code, and if we're going back or test it out with our Raspberry Pi, so this is the code or the another version of the traffic lights. So we can see we import the GPIO 0, the traffic lights from GPIO 0, slip from time, and we add additional line which is the pause from signal module. So we declare that the pins used for the traffic lights are GPIO 2, 3, and 4 like the previous one. But this time, we created a we created the function named traffic light sequence. So for Python, to declare a function, we will type def. So traffic light sequence function, and it is under the while loop. And this time we have yield, which is 0, 0, 1, or it's the green. So as we can see that the traffic lights are um, in a sequence of red, amber, and green. So we can see it is in a form of a matrix. So we can see that the green lit first for 10 seconds, the next one for the amber for 1 second, then for 10 seconds, which is the red, and then red and amber for about 1 second, and then the loop uh, continue continue, or it will repeat these lines indefinitely. And then we call out the sort, or we call the function itself lights.source equals traffic light sequence. So this means that we call the function, which is the traffic light sequence, and with a pause function to run the code. So let's try to run this code by clicking this button, and let's see if works with it if it is working with the same with the previous one. So as we can see, the green light is on, so it means of our traffic light system, and we can see that it works the same as the previous one. So if we can use those codes in programming our traffic light system, as long as we have 3 LEDs and connected to the designated output GPIO pins we declared in the program. So we can see that the green is connected to GPIO4, the red is connected to GPIO2, and the amber is connected, or the yellow LED is connected to the GPIO3, and all of them are connected to the ground. To do the exercises, which are the two-way traffic light system and the one-way traffic light system with pedestrian button control. So let's try the two-way traffic light system. Going back to our monitor, we modify the first version of the code of the traffic lights. So we can see we import the libraries are the same, but we add another set of traffic lights, which is named as lights 2. So when we create the circuit, we add another red, amber, and green LEDs. So we can see the added code. The added GPIO pins is from pin 7, pin GPIO 17, 27, and 22. So the red light is in 17, the amber is on the 27, and the green light is on GPIO22. So, since it is a two-way traffic light system, it should be the other light should be the opposite of one. For example, if the traffic light is on green, the other should be red and vice versa. So with that, we program it that the traffic lights with the name of lights is a green one, while the other, which is the lights 2, is a red one. So we can embed it on the code, like we both lights 2 and of the red and the amber are is the same as the earlier version. So if the green is off, the lights 2 of the red LED of the lights 2 is off, but the amber of both traffic lights are on with a delay of 1 second. As we can see, we just replicate some lines of the code. So, like for example, the amber is off on both traffic lights, but the lights on the red one, from the red one on the lights is on, but the lights 2 with green is on with the delay of 10 seconds, the same as these two lights are on again and then go back to its original state, which is, as we can see, the lights the green the green is on, but on lights 2 the red is on. So we almost replicate the code in to have a two-way traffic light system, although it composes of 30 lines, but it should do the work. So let's try to run this one and see how it performs. So the code is uploaded, so we can see that the first one, the green LED, is lit and the other one is red. So as we can see, it reverses now. So the first one has a red LED and the other one is green. So this determines that we created a two-way traffic light system in which the traffic lights are illuminating oppositely to avoid any disturbances, or it took to avoid any obstruction on the traffic flow for each lane. So since we assume it is a crossed path, so for a two-way traffic light system, the other should be on the go state or flowing, while the other one should be stopped and able to give way for the other lane. Traffic light with pedestrian, or this is the code for the traffic for a traffic light with the pedestrian button. As we can see, we modified the code again and we added a new function, which is the button, since it requires a button. So we replace traffic lights with asterisk to import all of the necessary libraries. So and then from time we import slip. With that, light, lights are the same, which is 234, but we added a button at GPIO 17. So it is the same here until line 21, but we reduce it to 5 seconds instead of 10. So now, as we can see, there is a wait for press. It means when the button is pressed, the red light will be on to stop, for example, the incoming vehicles. Then the amber will be off and the green will be off. And then it will wait the button to release to resume the loop again. So let's try to run this and see how it works. Let's try to run this script and let's see how it works. So this is the circuit of pedestrian lane of traffic light with pedestrian button. So we can see it functions like a traffic light but with a button. We can see now that that the traffic light works on a sequence like we programmed earlier in a two-way traffic light system, and the test of two versions of code to determine if the code is working properly for a traffic light system. So to test this code out, we should press the button. So for this one, as of now, the current state is green. So if we press the button, it will instantly turn to red, where we can say that someone is going to cross the road. And now we can see that it's still red, or it will back to the normal version or the function of a traffic light system. And now we can see it is back to green. Hope you like this video and see you again next time.